Folks, welcome to the demonstration on traveling booking app. I'm trying to do this video recording because we did not have enough time to discuss this application. So as you can see, this travel booking application is running a back-end, front-end, and it is also using a few set of tools. One for logging, one for monitoring, another for externalizing configuration files, and the last one being the Nginx, which is the load balancer, ingress, and all these things. Okay. So this particular application chooses the backend to be Python and the front end to be React and White. So this was the very simple application I was attempting to run during the class demo, and we did not have enough time to walk through the entire setup, so that's why this particular demo. So you guys know the course website, and you know that the GitHub link has been already distributed. If not, I'll send a message again, not to worry. So if you look at this travel booking app is what is basically being discussed now. Now, to make things simple, beyond the compose file, which is basically for the Podman desktop to work, I've also made a batch file to test the composition. And there is also a separate batch file to test if the Redis works very well. So let's take a look at what's happening in this set of framework and technologies being put together, and how do you go about building one and then making sure that this runs, etc. So for this, I'm basically using different technologies and frameworks. So front end is a progressive web app. The back end is a very simple CRUD kind of service, which is directly connected to MongoDB for persistence, and it also uses Redis as the medium for caching and session. And of course, it also makes sure that the reverse mapping is possible, so CORS is enabled. And additionally, to support the platform concerns and infrastructures, we have a few health, logging, and other services running. So these are the port number details and the libraries that the application is dependent on. So let's get started. The way it goes is you got to create a very simple hosting on containers and launch them, so that anytime the browser makes a request, the load balancer takes it up and then distributes the request to the endpoints, which is inside the backend. And of course, backend will always try to fish out the data from Redis if possible. Only on a cache miss it goes to the Mongo to be able to query the data and get you the results. So this basically gives you a reduced latency. So you need to create the project structures and other things. So when I want to initialize the project, I have to run the make script with the init setup or flag. Then I build the code. Then I try to compose up by using makebat.up. And then of course I have to wait for some time for the services to come up, and then I will be able to do the testing. So this is pretty much what is a very simple flow, and of course we will come back and revisit the other steps. So when you open up the workspace in Visual Code, it is going to look something like this. So you have the back end, front end, monitoring logs, which has got a container file, and logs, which has got a log settings and so on and so forth, and a configuration file that talks about additional configuration that is useful for. One is for MongoDB and the other is for Redis. So these are basically external configuration files that are handled. Now I go into this particular subfolder, and so my first job is to make sure that I create all the initial folders that are necessary. So I'm going to look for makebat, and then I'm going to say init the folders. So this initializes the project. The next time I will want to build the code, so I'm going to ask for a build code. So what happens during this step is basically it goes through a set of container files, both on the front end, back end, then on the Nginx, and all the other kind of container that I've specified inside the container file. So if you take a look at the container compose file, which is common for everything, you will see we create a container for Nginx, we create another container for front end, and one for backend, and then this is supported by two other containers. One is on Redis and the other is basically Mongo database. So these are the number of images that the system has to create. So how does it create a front end, for example? So when you look at the front end, it is going to pick up the container file, and then it knows it is going to be a Node.js image. It packs up all the dependencies specified, it installs the dependencies, it gives the execution rights, it exposes the right port number, and then it also gives commands to start giving the installation execution. The same way, when the node balancer container file is opened, it also picks up the nginx copy, it exposes the port default, and then it also starts producing nginx command line prompts. Very similarly, in the backend, you create it from a Python file, so you can see that we are pulling up a very slim version of Python, and then of course it's trying to get in all the required software from the requirements.txt. It iteratively installs each of them, copies them in the right places, opens up the log files, and then the container files are created. So you can see that each container has got a several set of steps, Linux or otherwise, and your command prompt is going to go through everything to create appropriate container images. So once the build is successful, when you go back to your Podman desktop and you look at images, you can see that relevant images would be created. Okay. So you can see that there are this travel, front end, back end, monitoring, nginx, Python, so on and so forth. So if you look at all the public images like Redis, Mongo, Python, nginx, Node, they would have been changed or checked in on different times. So you can see that Node seems to be the oldest. It was changed 1 month ago. Python seems to be the most recent because there was a change 2 days ago. But if you look into my travel app images, all of them were composed and tested yesterday night, so you can see they're roughly 16 hours old. So all these images are up to date and they are ready for us to start composing the application. So in order for us to compose this application, what we tend to do is we'll go back here and then we'll use the same make command here. Okay. And then instead of build, this time we're going to say up the services. So what happens when this is produced is it basically has created manifest files based images. So these images tend to be run on the runtime depending on all the other runtime dynamics we have asked for. So once the containers are up, they've been very labeled very systematically. So there's front end, Redis, Mongo, back end monitoring service, and nginx. Each of them are created, and then subsequently the port numbers are exposed, and each port number has a way of testing. So everything gets launched into the container workspace eventually. So earlier when we looked at the container workspace in the Podman desktop, it was empty, but now when you click on the containers, you can see that there are 5 containers up and all of them running, and they are being composed using the travel booking compose app. And this basically means they take some time to set up and then run, but now every application is ready to be tested. So of course the opening port is via nginx, and you can see that it is port 8080 and it is active. So what I tend to do is I just try to test the front end first. So I use a control key and click the link. So immediately you can see that the travel app comes up. So I've been testing my travel app, so there are some old records. Okay? So if I don't want them, what I can do is I can delete them. So the new booking starts like this. I have to pull in a destination name. So yesterday I was showing a Melbourne example, so that's why you can see it's in the list. I can pick the same thing. And of course I'm traveling, and then I want to travel say in a future date, which is somewhere between 22nd October until Christmas, so probably it's the 26th. And then I'm the only person trying to do this booking. So when I say create a booking, it creates the booking. And you can do this via your front end, you can do this via your API. And the best part is, because this is a progressive application, it doesn't have to be always via browser. You can install this app. As you can see, when you say open the app, it opens up. Now what is interesting here is once you start handling it as an app, of course you can also try a different destination here. So I can say I'm trying to go to Chennai maybe next week for a couple of days, okay? And then I create another booking. So there are multiple bookings that are happening here, and you see it is quite responsive. As I said, depending on how I resize my application and screen, it's going to orient or expand itself. So it's quite a responsive web. It also has got offline memory and plenty of things. Okay? So this is what makes Progressive Web App a very interesting way of using this for doing any typical installation. Okay? So that's pretty much what we have on the demo. Now, having tested the demo, the next part is to see how you can open up the backend and then see things for yourself. Of course, the general backend is basically localhost and 5000. This won't work because instead what you can do is you can look at 8000/API/bookings. So this basically gives you a very simple, even that is not 8080, sorry. So you can see that it gives you a very simple way to see what the backend is holding at this memory as of now. So you can see that it has got 2 records currently, and the JSON data is being declared here. Now, even more interestingly, what you can do is you can do Postman agent, and which is basically useful for testing, and you can use this to create new records inside the system if you'd like to do API based testing. So I gotta wait for that to come up, and sometimes what happens is I have to start the Postman agent in administrative user rights. So that's something funny about Microsoft. So let me start this. Say run as administrator. So it has to go through the access rights, and I say yes, it starts. And if you think about why the travel booking app is behaving weird, I have an icon. So when I install it as an app, you can see that it already creates a shortcut for me inside the application. See, the additional set of codes that you may have to do for this to be working is in your front end. You will probably write a white configuration file. So the white tells me what kind of features that I would like to use in my Progressive Web App. And you can see this is where I sort of resize images for different screens. So along with the public JSON files that I have, I start putting in icons which is of different sizes. So depending on the device, it's going to pick the icon. Okay, so it's very easy to create icons. You just have to say PWF image generator. That's a website that helps you to create a very standard set of icons for mobile phones, tablets, and websites, and multiple monitor websites and all that. So you can use that and do public images. In this case, I've kept it simple. I just needed one logo, and I wasn't very good at thinking what I want, so I always like owl pictures, as you know, so I just plonked in one so that you can see the application running. Okay. So this is for me. So let me see why, I don't know why Postman is not up. So let me try. Okay, so I was probably trying to do the agent. So now I have the Postman coming up. Okay, so that's fine. So let me see. I was trying to. Okay, so this is the get request. So similarly, I had a post request. So this is post, right? And if you look at the body of it, I've created a JSON. Okay, so I'm trying to fly to Paris. See, there is always this US username called John Doe. They use it basically for anonymous common man. And when I asked the LLMs about what is the common man name for Singapore, they said Abeng. Okay. So I thought it was something that was very funny, so I just used it. So you can see that I put some flying dates here, and I put some travelers, and I designed the object as a JSON object, and I want to use a post command to be able to create that. So when I send this, you will see that the record was successful. So that's why you get a 201 record successfully created message. Now if you go back and look at towards your backend state, you can see that there is this new record created to Paris with Gmail. So this is basically how the backend supports all kind of requests. Of course, you can also use Mongo Campus to go and see how the Mongo is created. You can also open up and see how the Redis is remembering things. So let's get down to that. Suppose you want to do the health check for your Nginx. This is basically a command prompt that you may wish to push into your terminal. So just look for curl the health, and then you will be able to immediately check for health conditions for your Nginx server. Okay, so you can see in this case I said when I started looking at the load balancer, it goes through the load balancer's health status. It gives me a 200, which is okay, and it says the connections are live and active. So that's basically how I health check my nginx server. Now you can do the same for your backend. You can do the same for the monitoring services if you're keen. Okay? And then if you say monitoring services, Redis and Mongo is being monitored, so their status is individually reported. And you can also look at logs, specific logs. Suppose I want to see the logs for Redis. I can copy this code and then try looking at the log files directly from my command prompt. Okay, so I'd say redirect all the Redis logs here. So you can see that Redis is basically useful when I try to read back data. So I created a record, and then roughly recently I basically listed them again, so you can see that these access to Redis has happened in the last few seconds. Okay? So it goes by the server-side timestamp hosting. So the last few seconds you can see that the records were into the Redis. Now you can also start playing around with inspecting the container with certain kind of tags and all that. So you can say filter all the container details that starts with travel. So if you're running many containers and you want to filter them based on a name tag, you can try that. Very similarly, you can also see what's happening in Redis. Okay, suppose you want to connect to Redis and see what's the current Redis like. Okay? What you can do is you can simply open up a command prompt, then paste the Redis CLI command inside, and then you can see that it gets into your Redis command prompt. And then of course you are free to try any legal Redis commands. Okay? So you can say list, you can look at the key value pair, and all those kind of things. Very similarly, you can also open up a command line prompt for Mongo database using your Mongo shell, and you can also try looking into Mongo commands. Okay? So you can say database.bookings.find, which gets you all the records and so on and so forth. And if you do not want to work on the shell, you can also give a complete command line that talks about shell, counting documents, and so on. So these are the different set of commands that happens inside your API testing. So we tried, instead of trying to do curl, you basically tried using Postman to create a record, delete a record, and look at the listing of records and so on. So if you want to start looking into network components testing, you can also use the ping tool. So you can ping your data servers, and you can look for connectivity and so on and so forth. The same way, you can also redirect your log files to a particular system. Okay? So you can simply say type log, the log goes to app.log and all that. So you can actually copy the commands and then play around with this, so nothing is lost. So it's quite easy for you to look at how things go. And once when everything is done, you may want to put down the systems. Okay? So you can simply say compose down. So it's podman space compose down, just like you say podman down. Or you can say make down. That's fine too. Okay? So either one of them will help you. Just like make.bat up is to build it up, you say make bat.down, it goes down. So in this particular workshop, what we have done is we have tried to comply with 12 native factors. How did we do that? We use single repository, GitHub. We explicitly specify dependencies in JSON and requirements. All the configuration files are called as .env, so we are externalizing config files. We run backing services, in this case databases like Mongo, and in-memory setup like Redis. And we use container files to do the build. Okay? So those are the Linux commands that are basically used to pick up the build and run them. And every application is decided to be stateless, so we don't have any state management issues. We are sharing ports. We are making sure the horizontal scaling is always done via containers. We have up scripts and down scripts, so disposability is satisfied. We use the same container configuration for all kind of production and pre-production releases. We capture all the log files in the system output stream, and we log them into simple text file structures. And make file commands is basically controlling all the administrative processes. So this is our simplest way of complying to 12NF. Of course, you can replace many of these things with more advanced tools if you want. So we hope that this basically gives you a full outline of how the travel booking app works. Okay? And of course, this is the entire project structure. We roughly saw how the codes work. So the front end is basically a main application called app.jsx. The rest of the task and booking comes from the component form. The service is exposed as an API, so if you want to understand how the booking app services work, you can take a look at this. And as mentioned, the Python backend is quite simple. Everything is inside the basic file, which we call it as the roots and models. Okay? So this basically covers how the mapping happens on the backend. It's a pretty straightforward container service we are using. And again, for monitoring, we use the basic free one that comes with Podman Desktop. Okay? So nothing sophisticated. So you can take a look at this. So if you look into the monitoring, you will see that there's a very simple Python container, and we are trying to run whatever default monitoring tool that Flask uses. In this case, it's requests. Okay? Same way in NGINX, we use the same for setting up the default configuration that comes inbuilt, and we are exposing port 80 as default. For the log files, again, this is the app log. Every time we have a log content or a transaction, you will see that this file starts growing. So this is where we go back and look for troubleshooting. Okay? So we see if there is any error state. We may filter this by error state and see what kind of things are happening. In this case, I just wanted to copy everything inside. So far, I don't have any errors. That's why you see the information, warning, those kind of things. You don't see any errors. If there is an outage that's happening, you'll be able to troubleshoot this inside the apps.log. And of course, we spoke about the ignore files. Git basically ignores all the machine and IDE generated code. Container ignores basically any kind of editor recreated and environmental details that we have. Here we are not using any sensitive API keys, okay? So that's why you don't worry. But in case you want to differentiate your development environment to production environment, you create .env files as we show here. You say .env.development, .env.integration, .env.uat, pre-production, production, and they're basically going to be the same setup that you want everywhere. Okay? So this is basically your secret files as we call them, and you want the Git to ignore them. Okay? So anytime you want to check in and check out, you want to ignore all those environment files created by the container. So that's why container ignore will have all the env files as common files to ignore. That's pretty much the entire demonstration. So I think we're done. So let me come out of Redis. Now what I can do is I can say make .bat. Down. So this basically brings down my current hosting. Okay? So I can simply remove all those unnecessary hosting that has happened so far. So when I say down, it has a sequence in it. Usually uses the reverse order of putting down the messages. So when we try to build the code, we do the forward order, and when we try to remove the code, we try to do the reverse order. So that's basically what is happening in this particular script. It takes a couple of minutes, and then you will see that all these containers are being dislodged. Okay? So you can see that they are being systematically dislodged, as you can see here. And all the running images are also removed, so that's why there's no current running images. However, the original images you created will be there. If you really want to rebuild these things again, you can simply delete them, prune them, and then start over. Okay? So, but the next time you create a build command, it's going to take a while, because it's going to take the official copies and then do all the Docker instructions again. Otherwise, it refires the Docker instruction only if the instructions has changed. So it's very smart that way. So that's why we keep calling all these kind of compiler instructions as declarative compiler instruction. So I hope this demo was quite useful for you. And of course, I didn't have time to talk about the other very key feature of Progressive Web App, which is offline storage. But then I'll leave it to the developers to explore. And every day there is a new technique about how we do state management. So keep up with this, and I think this gives you a basic understanding of how to run an app with different responsibilities inside the container, get them launched, and get your business function done. Thank you very much for the patient listening, and I hope this demo was some sort of easy for you to see how things are going. Thank you guys, and see you in some other demo.